In problem C4, we have a 25.3 kilogram crate falling off the back of AB's truck, traveling at 32.8 meters per second. So it's whipping this way at 32.8 meters per second. If the coefficient of friction between the crate and the ground is 0.897, so mu equals 0.897, how far along the ground will the crate slide? Well, if it falls off the back of his truck and it was going 32.8 meters per second, then it's going to hit the ground going 32.8 meters per second. So it's not going to fall off the back of the truck and roll this way because it was already going this way. So it's going to hit the ground moving this way, and it's going to slide until, of course, it stops. So we're looking for a V final then of 0 because it's going to slide till it stops. So 32.8 must be my V initial. What we're looking for is how far does it travel? So we're looking for that displacement. Now, of course, if I'm looking for displacement and I have VI and VF, there are two formulas I can choose from. I have VF and VI in a formula that looks like this, and I have a D equation that has VF and VI, and it looks like that. So basically, I either have a choice between I need to know A or I need to know T. Well, in this unit, we've been finding A a lot from A equals F net over M. So the A one is going to be the better choice. So we're not going to do this one. We're going to do this other one. So we already know the VF and we already know the VI and we already know 2. So really we just need to find A. But of course A is equal to F net over M. Well, we know the M that was given here as 25.3 kilograms. So that's here, but we don't know my F net. So then we say, well, we learned two F net formulas. Clearly the crate's going side to side, so this is going to be my applied force plus my friction force. And so then you say, well, what was my applied force? Well, who was pulling or pushing on that crate? And you say, nothing. So nobody was out there pushing or pulling on it. The only force there was the friction force. So if friction is my only force, then that is my net force. In this case, I don't have an applied force. So really this net force just turns into my friction force. That leads us to some nice, interesting algebra. I actually showed you this the other day, if you were actually paying attention. We remember that if the F net is really equal to the friction force, then that's just equal to FF over M, which equals mu mg over M. And then you say to yourself, hey, look, those M's, they like go away and they cancel. That means my A is really just equal to mu g. Now, you can't use this formula anytime you feel like it. This formula is only going to work when my only force is friction. So if friction is the only thing slowing me down, that happens when I am skidding. So I like to call this our skid equation, because if I'm skidding to a stop, if I'm just sliding into home plate or something along those lines, then this will work out fantastically well for us. That makes it super simple because it shortens it from a 3-step problem to a 1-step problem. We like that a whole lot better. So we're just going to have A equals mu g. So A, you say, hey, wait a minute, all we were missing here was A. And you're right, that's all we're still missing. So A is equal to mu g. We know our mu, we said, was 0.897. And then g, of course, is 9.81. And so that gives us an acceleration of 8.80 meters per second squared. Now, you have to say, is this a positive or negative acceleration? Well, if I'm skidding to a stop, this will always be a negative acceleration, because that just makes sense. So that'll be a negative acceleration. So now we're plugging again into that VF squared minus VI squared over 2A equals D equation. And my VF squared, of course, was 0. My V initial squared, we said, was our 32.8 meters per second, because that was how fast the crate was going initially. And that is squared. And then we divide it by 2, and we divide it by the acceleration that we just figured out was that. And if we plug in correctly, we get 61.1 meters, which is the answer. Hooray!